Left here, this is a fake data set where an individual went to 3 different urban sites and then 3 different forested sites, and they walked around for like 2 hours maybe, and they counted all the different birds that they saw. So this is just the data set here on the side, but the important thing here is that they're testing if there is a difference in the frequency or like abundance of birds in urban versus forested regions. So this is like the raw table. I always recommend making, I love color coding, and then I always recommend making a smaller table with just like kind of the summary data. So here, like what I'm really looking for, what my response variable is the count of the total number of birds found in each one of these sites. There are 3 urban sites and there are 3 forested sites. And so here are my counts, 24, 14, ranges from 12 to 53 birds. Now in my data tab up on the top here, I'm going to go to data analysis. And now I'm going to click on t-test paired to sample for means. There's a couple different t-test options, but here I'm looking to see if there's a difference in the average of birds found in urban versus the forest. So my 2 means. Sorry, this is so small on this computer. My variable 1 range is going to be my urban. So I'm clicking, I'm highlighting all 3 of my raw values, not the average, just the raw values. So I have 3. My variable 2 range, that's my forest. So for you guys, it might be like control versus the response, or control versus the treatment. I'm always going to assume that my hypothesized mean difference is 0. And I'm testing against like the standard 0.05 alpha, so that's like the p-value. My output range, I'm just going to pick a random cell. I'm just going to click this one here. I know that there's already the output here. So it's going to like say that I'm overwriting existing data. I'm just going to click OK. And then now, what is important here is the 2-tailed p-value, which is right here. So this looks for a difference on the positive side or the negative side. So that's being like urban being higher or lower than forested, vice versa. So 2 tails, 2 ways. And in this case, the p-value is 0.043. I've also just like, to make it a little bit easier, reference that cell here so you can kind of just see here. And so if we're testing against our kind of standard of 0.05 p-value, what is this significant or not? Yes. And so it's one thing to say, yes, this is significant. Thank you, that is what I asked you. Thank you for answering. In my write-up, I would say a little bit more than that though. I would be like, I found a difference in the abundance of birds in forested versus urban sites. I ran a 2-tailed t-test, a t-test with a paired 2 sample for means, and I found that my difference was 0.04, making that significant, making there a significant difference between the frequency of birds. So that is how you do that. And then for the graph, I think you guys are pretty like well accustomed now to that, but let's say I have my urban and then my forested. I would find the averages this time, so the average, and I'm just going to like select my 3 raw values, and then same with forested average. That's these ones here. This is my average. And then I also want my standard deviation, and it's kind of the same thing. You go standard dev is the equation. Press enter. Standard deviation again. like this. And then I would want to graph this here. So insert recommended chart, maybe like this. Let's call this abundance of birds. I have my urban and forested. And then I'm not going to go over the standard error, but again, you would like use the custom error bars and put them in there like that. It's very important to label your X and Y axis, create a legend, that sort of thing that I'm not going to do now. But there we go. We can see visually that there seems to be more birds in the forested site, and that is backed up here by our p-value. You don't have to do a line graph if you don't want to. You can choose something different this time. So maybe, actually, let's look at the recommended charts. Oh, this is kind of fun. Pie chart.
The histogram.
Or like the clustered column. I like this one. This is kind of like standard, you know.
Histogram.
And it's like the same thing with the standard error bars. I actually will show you with like a new option here. Specify your value. You just go in, custom standard error bars. There we go. Yeah. And then the other thing that I wanted to show you is I compiled Thursday's class data. And so for us, I think we did find a significant size difference. It was like 0.013, right? And then for temperature, it was kind of moderate at like 0.06, and we didn't find an interaction impact that was like 0.14, right? Something for the 3 p-values.